After the age of 60, the conversation about strength quietly shifts from performance to independence, and nowhere is this shift more biologically important than in the gluteal muscles. These muscles sit at the center of human movement, not as something dramatic or visible, but as a deep structural support system that allows the body to rise from a chair, maintain balance while walking, and protect the spine from unnecessary strain. From a scientific perspective, the glutes act as a primary bridge between the upper and lower body, transferring force efficiently so that joints and smaller muscles are not overburdened. As aging progresses, muscle fibers naturally decrease in size and responsiveness, a process known as sarcopenia, and the glutes are particularly vulnerable because daily life no longer challenges them the way it once did. Long periods of sitting send a powerful neurological message to the brain that these muscles are no longer essential, and the body, always efficient, begins to allocate resources elsewhere. What is remarkable is how reversible this process can be. The nervous system remains adaptable well into later life, and when glute muscles are intentionally engaged, the brain quickly relearns how to recruit them. This reactivation improves not only strength, but also proprioception, the body's internal sense of position and control. Scientifically, this means improved communication between sensory receptors in the muscles and the motor cortex in the brain. Functionally, it means fewer missteps, more confidence while walking, and a reduced fear of falling. Independence is preserved not through dramatic effort, but through restoring these quiet conversations within the body. There is also a deeper structural implication. Weak glutes force the lower back, knees, and hips to compensate, altering movement patterns in subtle but harmful ways. Over time, this compensation increases joint stress and accelerates wear, which is why back and knee pain becomes so common after 60. Strengthening the glutes redistributes load more evenly, allowing the skeleton to align as it was biologically intended. This is not about adding years to life, but about adding stability to each movement within those years. The body begins to feel safer to itself, and pain often decreases not because anything was fixed directly, but because balance was restored. From a reflective standpoint, glute strength represents something almost philosophical about aging. It reminds us that the body does not suddenly fail, it slowly adapts to how we ask it to live. When movement becomes smaller, the body becomes cautious. When movement becomes intentional again, the body responds with quiet resilience. Building glute strength after 60 is therefore not an act of resistance against time, but an act of cooperation with biology, honoring how the human body was designed to move, support itself, and remain capable even as the years advance. The simple act of sitting down and standing up, something most people stop thinking about until it becomes difficult, is one of the most neurologically rich movements the human body performs, especially after the age of 60. From a scientific perspective, this motion is far more than a leg exercise. It is a coordinated sequence involving the glutes, quadriceps, core muscles, spinal stabilizers, and the nervous system that orchestrates them all. Each time the body lowers and rises with control, motor units are recruited in a precise order, teaching the brain how to distribute force efficiently. As we age, this coordination often weakens, not because the muscles are incapable, but because the brain has lost the habit of activating them together. When movement becomes rushed or avoided, the nervous system defaults to compensation, allowing stronger muscles to dominate while others fade into inactivity. Research in neuromuscular science shows that controlled, repeated movements reawaken dormant neural pathways. When an older adult performs a slow sit-to-stand, the brain is forced to pay attention again. Sensory receptors in the muscles and joints send feedback upward, informing the nervous system about position, tension, and balance. This feedback loop sharpens proprioception, the internal sense that tells us where our body is in space. Functionally, this translates into smoother movement, less hesitation, and a growing sense of trust in one's own body. Confidence in this context is not psychological optimism, but a measurable improvement in neural efficiency. There is also a metabolic intelligence in this movement. Rising from a seated position demands a brief but meaningful surge of muscle activation, which stimulates blood flow and oxygen delivery to tissues that often suffer from reduced circulation with age. This improves nutrient exchange at the cellular level and supports mitochondrial function, the tiny energy centers inside muscle cells. Over time, these repeated demands signal the body to preserve muscle mass rather than dismantle it. The body responds not to intention, but to necessity, and this movement quietly reestablishes that necessity. Beyond the biology, the sit-to-stand carries symbolic weight. It reflects the transition between rest and action, between stillness and engagement with the world. When performed mindfully, it becomes a reminder that strength is not always loud or aggressive. It can be slow, deliberate, and respectful of limits. Each controlled rise reinforces the idea that the body is still capable of learning, adapting, and improving. In this way, the movement becomes a dialogue between patience and persistence, where scientific principles of motor learning merge with a deeper understanding of aging as a process of refinement rather than decline. The backward movement of the leg, known biologically as hip extension, appears simple on the surface, yet it reveals one of the most important truths about how the human body protects itself, especially after 60. This motion primarily activates the gluteus maximus, the largest and most powerful muscle in the body, a muscle designed not only for movement, but for protection. When functioning well, it absorbs force, stabilizes the pelvis, and shields the lower spine from excessive load. As aging and inactivity weaken this muscle, the body does not stop moving. Instead, it adapts by shifting the workload to the lower back and hamstrings. Science refers to this as compensatory movement, and while it allows short-term function, it often leads to chronic discomfort and structural imbalance over time. From a neurological standpoint, hip extension reestablishes a fundamental pattern that humans developed through walking, climbing, and rising from the ground. These patterns are deeply wired into the nervous system, yet they become underused when modern life removes the need for powerful hip-driven movement. When the gluteus maximus is deliberately engaged through controlled leg lifts or gentle extensions, the brain is reminded of an old map it once used every day. Motor neurons increase their firing efficiency, and muscle fibers that had grown quiet begin to participate again. This reactivation does not require intensity, it requires consistency and attention, allowing the nervous system to refine control rather than rely on force. Biomechanically, strengthening hip extension restores fairness within the body. The pelvis becomes more stable, allowing the spine to maintain a neutral position during movement. This reduces compressive forces on the lumbar vertebrae and decreases the strain placed on smaller, stabilizing muscles that are not built to carry large loads. Over time, posture subtly improves, not because one is trying to stand straighter, but because the structural support beneath the posture has been restored. Pain often diminishes as a side effect of balance rather than as a direct target of treatment. There is also a quiet psychological effect. Chronic back discomfort can change how a person relates to movement, introducing hesitation and fear. When hip extension exercises are practiced regularly and discomfort begins to ease, the body relearns safety. This sense of safety is biological before it is emotional, rooted in improved stability and predictable movement patterns. The individual begins to move with less guarding and more fluidity, reinforcing the cycle of recovery. At a deeper level, strengthening the gluteus maximus through hip extension reflects a respectful approach to aging. It acknowledges that the body does not need to be pushed beyond its limits to heal and adapt. Instead, it needs to be reminded of its original roles and allowed to fulfill them again. Through this simple movement, science and self-awareness converge, restoring balance between strength and support in a body that continues to carry a lifetime of experience.
Sideward movement of the leg, often overlooked in favor of forward or backward actions, reveals a critical dimension of human stability that becomes increasingly important after 60. This motion primarily activates the gluteus medius, a muscle that plays a central role in keeping the pelvis level during walking and standing. From a scientific perspective, this muscle acts as a stabilizer rather than a prime mover, quietly correcting imbalances with every step. As aging progresses and physical activity narrows, the nervous system receives fewer signals to maintain this lateral control. The result is not immediate weakness, but a gradual loss of precision, where balance becomes less automatic and more fragile. Research into fall prevention consistently highlights lateral instability as a major risk factor, often more significant than the loss of forward strength. When the gluteus medius weakens, the body compensates by shifting weight unpredictably, placing stress on the knees, ankles, and lower back. These compensations are subtle and often unconscious, yet they increase the likelihood of missteps and falls. Sideward leg exercises reintroduce a controlled challenge to the balance system, forcing the brain to recalibrate how it manages weight transfer and alignment. Sensory feedback from the hips and feet travels rapidly to the brain, sharpening reflexive responses that protect against sudden loss of balance. Neurologically, this type of movement trains what scientists call anticipatory postural adjustments. These are pre-programmed muscle activations that occur before the body even recognizes instability. With age, these adjustments slow down, not because the brain is incapable, but because it has fewer opportunities to practice them. Sideward movements create these opportunities in a safe, intentional way. Each repetition strengthens the timing between perception and action, allowing the body to correct itself earlier and with less effort. Balance becomes less about reaction and more about quiet preparedness. There is also an important connection between lateral stability and confidence. Fear of falling often leads to reduced movement, which further weakens stabilizing muscles and accelerates decline. When sideward leg exercises are practiced regularly, stability improves, and the nervous system begins to trust its own responses again. This trust is measurable in smoother gait patterns and more symmetrical movement, but it is also felt internally as a sense of groundedness. Movement no longer feels like a risk to be managed, but a natural expression of control. On a reflective level, lateral strength represents adaptability. Life rarely moves in straight lines, and the body mirrors this truth. Training the gluteus medius teaches the body to respond gracefully to shifts, changes, and unexpected challenges. It reinforces the idea that resilience is built not only through forward progress, but through the ability to stabilize when life moves sideways. In this way, sideward leg movement becomes both a biological necessity and a quiet lesson in balance that extends beyond the physical body.
Holding the body in a lifted, supported position, such as during a bridge-like posture, reveals a form of strength that is often misunderstood, especially after the age of 60. Unlike dynamic movements that emphasize motion, this sustained effort activates muscle fibers designed for endurance and postural support. From a physiological perspective, these slow twitch fibers are essential for maintaining alignment, protecting joints, and resisting fatigue throughout daily activities. As aging progresses, these fibers are often understimulated, not because they fail, but because modern movement patterns rarely ask the body to hold itself steadily against gravity. When this demand is reintroduced in a controlled way, the body responds with renewed stability and confidence. Scientifically, sustained holds create continuous muscle tension that enhances neuromuscular efficiency. The nervous system learns to recruit just enough muscle activity to maintain position without unnecessary strain. This refinement is critical for older adults, as excessive tension can increase joint compression and discomfort. By practicing steady holds, the brain develops a more economical relationship with the muscles, conserving energy while improving control. Circulation within the working muscles increases, delivering oxygen and nutrients that support cellular repair and metabolic health. Over time, this contributes to improved muscular endurance and reduced feelings of weakness during prolonged standing or walking. There is also a profound connection between sustained strength and spinal health. When the hips are lifted and held, the gluteal muscles work in harmony with the core and lower back stabilizers to support the spine. This integrated effort reduces shear forces on the vertebrae and encourages a neutral spinal position. Many individuals experience reduced back discomfort not because pain is directly targeted, but because the supporting structures begin to share the workload more evenly. Stability becomes an emergent property of cooperation within the body, rather than effort imposed on a single area. On a psychological level, holding a position requires patience and focused awareness. The body may tremble slightly, not as a sign of weakness, but as evidence of neuromuscular adaptation. These small oscillations reflect the nervous system making constant micro-adjustments to maintain balance. For older adults, learning to remain calm within this effort can shift their relationship with physical challenge. Strength is no longer associated with force or urgency, but with presence and control. The body learns that it can remain steady even when effort is sustained. In a broader sense, sustained holds offer a metaphor for aging itself. Life after 60 often requires the ability to maintain rather than chase, to support rather than push. By building endurance in the glutes and surrounding muscles, the body practices this philosophy at a biological level. Stability becomes an active process, one that preserves dignity, mobility, and trust in the body's ability to hold itself upright through the changing rhythms of time.